signed by General Director of Nefti Dr. Елисей, but not ours.
Of the molecular elements if G is 1.74 nanometers, its value will be used in following. So let's go to the experiment. Here is on the slide the sequence of the experiment. First, the microcrystalline cellulose has obtained from the initial microcrystalline cellulose by its regeneration. Second stage is absorption, which includes dispersion of sample cellulose in Rodman 6G solutions, and then shaped under 160 RPM during 24 hours. Next stage is centrifuging. After that, we obtain final Rodman 6G solutions that goes to fluorine spectroscopy to measure its concentration. Also, we measure concentrations of the initial solutions of Rodman 6G. So the difference between initial concentration of Rodman solution and final Rodman solution gives us amount of absorption by cellulose sample. So let's get inside of first stage is the regeneration of microcrystalline cellulose. It's kind of classic method, also well known as mercerization. It is firstly treatment by sodium hydroxide, and then the mixture was cooled at -20 degrees and melted at ambient temperature. The cycle of cooling and melting was repeated 3 times. Next stage is neutralization by hydrochloric acid to precipitate our cellulose. Then we wash by water this mixture we wash until there is no chlorine ions in there. So then we filtrate it, obtaining our prepared sample regenerated microcrystalline cellulose. So let's go on. Here is experimental results. After fluorescence spectroscopy, we get amount of points of amount of absorption by each sample of cellulose. We can see extrapolated Langmuir isotherms, and also Langmuir equations on the right side of the slide. You can see that curve goes up and then goes to constant. This constant is A with infinity suffix. It applies maximum amount of absorbed molecules of rhodamine 6G as monomolecular layer on the surface of cellulose. Also we see that this amount of molecules absorbed by cellulose is higher for nanofiber cellulose. Regenerated cellulose has less amount, and microcrystalline cellulose has at most little amount of absorbed molecules. This constant, A with infinity suffix, used to calculate specific surface area of each sample of cellulose. You can see that process of regeneration of microcrystalline cellulose leads to augmentation of specific surface area in about four times, but it is lower than nanofibrillary cellulose. It's not, method has to be modified. So now let's see to the photos of scanning electron microscopy. Here you can see it's obvious that particles has more little size particles of regenerated microcrystalline cellulose. So it confirms our our conclusion that regenerative cellulose has has higher absorption capacity than initial microcrystalline cellulose. So that gets the conclusions. There on the slide, I have to say that use method of regeneration microcrystalline cellulose leads to augmentation of specific surface area, but not enough to reach nanofibrillary cellulose. So the method have to be modified. The research is a little contribution in this field. So that's it. So I'd like to field your answers now.
Thank you. Excuse me, I missed the MCC silk carboxyl cellulose.
No, it is microcrystalline. Crystalline. Yeah.
Please, questions. Yes, please.
You measured surface area used in two use. So what method did you use to calculate surface area of your
Method, Langmuir method.
Good or bad?
Yeah. Langmuir. Yeah.
So
It's more molecular. Absorption.
You suppose one layer absorption. Not
Yeah,
multiple
this is just theoretical. That it is monolayer. We didn't use that method, that polylayer absorption, because if we use that method, we have stage of preparation includes drying of sample, and as a result, pores has been destructed. So specific surface area, actual specific surface area is changed. It's been changed.
Yes, please. See. Tell me, please, what is condition your choice of your choice related to this adsorbent? What does it mean? This is adsorbent, but this is a chemisorbent.
Choice depends on its bioavailability. I mean, also used adsorbents from synthetic polymers, for example. It's less biodegradable.
Adsorbent.
Yeah.
But this is a very low surface.
Yeah, but
It's a specific surface. It's very low.
Yeah, but it is just a little step in this field, in this direction. There's not many research in this field.
What is structure of the pore? What is composition
Structure.
of this pore?
Structure is on the bottom here.
This is micropore.
Yeah.
Micropore is
No.
don't process by adsorbent activity.
Micropore.
Whereas mesopore processed by high activity absorbents.
No, we didn't measure size of pores. We just measured. We have comparative analysis of specific surface area. That's all.
Excuse me, please. Switch off.
More questions?
Excuse me.
It's not clear why you choose cellulose for water treatment, because cellulose is hydrophilic material, and you try to treat water which contain organic compound. Maybe activated carbon better for this use.
Yeah, they use carbon is
investigate the investigation of scientific, some scientists which work in this field, for example, Smirnov, do you know?
About carbon?
About carbon, about cellulose, about all
There's
kind
no-
of absorbent which is used for water treatment.
I just know investigation on my department. It's not because.
You'll find later of materials, publications on the issue. More questions? No? So the dissertation is equipped with reviews. First review, initial review is signed by head of Department of Chemicals, Industry, Biotechnology and Medicine, Dr. Konstantin. And the second one is signed by the supervisor of this dissertation, Assistant Professor Novikov. Both reviews are positive. So we shift to bachelor's applications. First, application by Makharova Arina for work development of emulsion compositions for depleted fields layers acidizing. And this research was supervised by Assistant Professor Dalech. Yes, you may.
Good afternoon. My name is Makharova Arina and I'm last year student of Bachelor Degree Program of Chemical Technology for Oil and Gas Industry Department. Today I want to tell you about my science work, which is about development of emulsion compositions for depleted fields layers acidizing. So before talking about the acidizing and the technologies, it's necessary to understand the aspects of depleted fields. So depleted fields, the fields which exploration has moved on the final stage, and by this time around 80% of recoverable oil reserves have been extracted. Of course, during the main period of development, a lot of processes took place, and as a result, there are a lot of complications at the final stage. For example, the processes leading to changes in oil compositions such as interaction of oil with the rocks when heavy oil components absorb, and as a result, the light oil is recovered at the basic period of development, and the heavy oil in the final stage. Evaluation of gas from oil when formation pressure drops below the saturation pressure, and the interaction of oil with injected water, and as a result we have the oil oxidation, bacterial destruction, and solution of light components of oil in the water. And so this leads to increase of oil density and viscosity, and as a result the decrease of oil mobility and layer. The next processes which leads to changes in porosity and permeability is the collimation, leading to reduced permeability, formation pressure decline, which is used to reduce porosity, and formation of water wash zones due to the high level of water cut. This leads to deterioration of permeability and porosity properties and high level of water cut. So all this leads to the fact that it's necessary to apply new technologies for achievement the main purpose of depleted fields development, as the decreasing of water cut and increasing intensification of oil production. One of the promising technology for depleted fields layers acidizing is using of inverse acid emulsions. It may be used for different conditions: high and low temperature layers, carbonate, heterogeneous formation. Such compositions make it possible to slow down the reaction rate between the acid and the rock, and they create the deep channels to the increased permeability. Also, corrosivity is reduced, and due to their hydrophobic nature, they are able to deviate from drain zone and act in low permeable zone. As we all know, emulsions consist of three main components. Inverse acid emulsions consist of hydrocarbon as an external phase, acid solution as an internal phase, and oil soluble surfactant as an emulsifier. The purpose of my work was to select compositions for low temperature layers. So, kerosene was chosen as an external phase due to its easily adjustable viscosity properties and ability to solve certain sediments in low temperature conditions. Three oil-soluble surfactants was chosen as an emulsifiers due to their stabilized and worse emulsions. And as an acid solution, we chosen sulfamic acid solution at concentration of 5 and 50% by weight due to the advantages over hydrochloric acid, and they are described in the screen. Objectives of my research were determination of emulsion preparations method and laboratory studies, comparison of the obtained emulsions properties, and the study of the components' concentration effects on the stability of emulsions. So, all researches were conducted in 20 Celsius degrees due to its an average temperature of low temperature layers. There were two preparation methods and a laboratory study of emulsion phase density, emulsion type, stability in time, electrical stability, dispersion, and effective viscosity. So, the first step was the determination of preparation method. A dispersant was chosen with rotation speed of 15,500 rpm due to the 1,500 rpm did not provide the stable formulations. As you can see from the graph, the most appropriate time of mixing is not less than 10 minutes. Density of emulsions were measured for assessment the effects of concentration changes of internal phase when changes the concentration of acid emulsion in internal phase. The emulsion stability in time indicates the ability of emulsion to be resistant to separated, and as you can see from the first table, the emulsions which marked green were unstable and weren't analyzed further. So niftenolone Z is not appropriate for stabilizing these emulsions. And I also want to know that the increased opacity acid solution concentration density leads to decreasing of stability of emulsions, and as a result, 3% of gidrophilizator ABR and niftenol NZB didn't provide the stability formulations also, and these emulsions were analyzed also. The remaining compounds marked in green were analyzed in next studies. Electrical stability make it possible to quantify the stability of emulsions and predict the possibility of global coalescence. And how you may see from the second table, the higher value of electrical stability shows the emulsions we were stabilized by gidrophilizator ABR. So why did we obtain these results? Results depend on the nature of the surfactant. So we saw that niftenolone Z is not appropriate for stabilizing these emulsions, but niftenolone ZB, which consists of niftenolone Z plus colloid system, is appropriate. Gidrophilizator ABR is a polymer surfactant, that's why it provides the highest value of electrical stability due to the formation of strong resistant covering as a phase boundary. And I also want to know that it means that the stability of emulsions depends not only on concentrations of surfactant, but also on their nature. Next step was the dispersion, which indirectly characterizes the sedimentation stability of our emulsions and make it possible to match pore size with global size. And here I want to know that the higher the acid concentration in internal phase of emulsion, the more effective is acid treatment. And the higher the dispersion of emulsion, the longer the emulsion is stable. So according to this table, emulsions which were stabilized by gidrophilizator ABR and simultaneously containing 15% by weight of sulfamic acid solution had more dispersion and the smallest size of globule. Rheological properties show the resistance of emulsions against flow. The lower the effective viscosity, the less energy is needed to pump these emulsions into the low through the pipes. As you can see from the first graph, the lowest effective viscosity shows the emulsions which were stabilized by 5% by volume of niftenol NZB and gidrophilizator ABR and containing 15% by weight of sulfamic acid solution. Effective viscosity is based on dispersion. The higher dispersion of emulsion, the higher effective viscosity of these emulsions. And also there is a larger difference between properties of these emulsions and properties of Newtonian liquids. But as you can see from the second graph, emulsions show no strong deviation from the properties of Newtonian liquids. And here you can see the equation of shear stress from shear rate. And according to the law of Ostwald and de Waal, the nonlinear index shows the rate of inclination of emulsion consistency curve from describing Newton's law about Newtonian liquids. The index n is most deviated from 1 in case of the first emulsions because it's highest dispersion. In the other cases, it's deviation less than 1/10, and if this deviation in the side to decrease from 1, it means that we may consider them the pseudo-plastic fluids. It means that their viscosity decreases with share rate increasing, and it means also that for them not too much energy is needed to pump them through the pipe into the layers. So I'm going to my conclusions. The most appropriate concentration and nature of surfactant, it's niftenol in the B, in iodophobizator EBI, and 5% of concentration. Concentration of sulfamic acid solution in water solution 15% by weight. Phase ratio 25 to 5 to 70%. It's needed. It's a more appropriate mixing rate 15,500 ppm. Mixing time 10 minutes. As a result of my work, 6 properties of emulsions were analyzed, and in future we plan to conduct dynamic studies on filtration unit to evaluate their abilities on real models and to conduct researches and the emulsion dissolving capacity. So thank you for your attention. I will be pleased to answer your questions.
Thank you, Irina, for your very energetic presentation. First question: is it your own recipe for depleted fields?
No, of course, I was held by my
It's better than all other recipes.
I think that it wasn't analyzed before.
Oh, good. Next question.
Are you sure that you really use lamp kerosene? Which of Russian refinery now produce such product?
We bought it in Russian one company. I don't remember this name, but we chose lamp kerosene because of absence of additives. Because we also plan to conduct research on interfacial tension, and the extra additives will be harmful for the result.
And really, it's not lamp kerosene. It's something like a kerosene fraction from
According
refinery.
to quality certificate, it was lamp kerosene.
So, very interesting. Thank you.
Trademark.
I think they take aviation fuel and
Good.
drill some.
No patient, please. No patient. Good, thank you. This question accompanied with reviews. One review is signed by this one. Yes, it's a single review by supervisor of the project, senior lecturer by This review is completely with the project. So we go to the next candidate. Next candidate is Nikitина Irina. With her presentation research of the religious works. Mineralogical composition influence on gel-generated system properties. And this work was done under the supervision of senior lecturer Pateshko, right?
Yes.
Please go ahead.
Good afternoon, ladies and gentlemen. My name is Irina Nikitina. Let me present you my diploma work, research of the heterogeneous rock mineralogical composition influence on the gel-generated system properties. Most of the fields in Russia are in the last stage of the development. This stage can be characterized by the high water cut, 90% or more. High water cut can be caused by water breakthrough into highly permeable formation, and this consequence of this process is a reduction of oil recovery. This problem can be solved using flow diverting technologies, which are based on the injection of special reagents into the injection wells. These reagents are designed to reduce permeability of highly conductive layers and deep equalization ductility profile. The CRE Oracle Chemistry has developed gel-generated system based on aluminium polyoxychloride, 1 and 6. The main goal of my work is to study this system and identify the influence of the heterogeneous rock metallic composition on the properties of these systems. You can see a mechanism of gel generation on the screen. Gel generation is due to nucleation and growth of polymer and methane particles in the system. The formation of alloxane particles is due to formation of OH ions. The formation of OH ions is caused by carbamide hydrolysis. General property of the system is gel generation time. This one has short gel generation time and 6-cell has long gel generation time. Because it includes special additive, sodium acetate. Sodium acetate decreases the growth of polymer and methane particles. From the mechanism can be seen that the main formation of OH ions has a great influence on the gel generation time. According to the mechanism, it can be seen that particle sizes for the system are different. 6-cell has small particles, and this one has a big particles. The small particles of 6-cell can be associated with special additives, sodium acetate, that suppresses growth of alloxane particles. So main factors that impacting on gel generation time are temperature, number of crystallization nucleus, and pH. pH depends on heterogeneous rock mineralogical composition, ions, alkaline and alkaline earth metals in clays and carbonates, and components of H water and bottled water. The increase of temperature and pressure is due to carbamide hydrolysis. Hydrolysis begins at the temperature of 40 degrees Celsius and its rate increases with temperature increasing. The area of the interest of this work is heterogeneous rock over Siberia, so the temperature of researchers was 85 degrees Celsius. As can be seen from the reaction, equilibrium of the hydrolysis shifts to the carbamide formation with pressure increasing, but the parallel process of gas solution in water proceeds. So, pressure does not influence on the gel generation time. Firstly, the influence of the number of crystallization nucleons was studied using percent as a rock model with different content of sand in every sample. As can be seen from the graph, the compositions behave in the same way. The gel generation time decreases with increase in the share of sand. Because this work is about heterogeneous rock, we need to speak about composition of heterogeneous rock. Heterogeneous reservoir composed by skeletal frame from quartz and oligoclase and cemented by clays and carbonates. Clays and carbonates contain ions of alkaline and alkaline earth metals like sodium, potassium, calcium, and magnesium. Hydrolysis of aluminum polyoxychlorides produces hydrofluoric acid, and this acid can react with salts of this metal in the cement of the rock. So, concentration of H ions declines and pH shifts to the alkaline. Further studies was made using the rock model in addition to sand, clays, or carbonates. As can be seen from the graphs, compositions behave in a different way. If this one can be characterized by a linear decrease in gel generation time, then for 6 it decreases exponentially, which can be associated with an intermediate compound. In the study of mixtures consisting of clay, carbonate, and sand, it was found that they have different influence on the gel generation time. Gel generation time decreases with an increase in the share of clays and carbonates, like in the previous cases, but the influence of carbonates is more than clays. It can be associated with a great share of alkaline earth metals in these minerals. Because in real rock, allocation of compounds are different than in our model, it's necessary to study the gel generation time on a real core. Firstly, a mixture analysis of core composition was made, and as you can see, core contains 16.5% of clay and 2.5% of carbonate. And the gel generation time for the real chrome showed a significant decrease for Sixel and insignificant for Vis1. But this time is different from the time that would have been on an artificial model. So we can make the following conclusions. Gel generation time decreases with an increase in of listed factors like a number of crystallization nucleus, place and carbonate content, and temperature. Pressure does not impact on it. It's obvious that for the most efficient equalization activity profile run by operation, the chemical composition of the reservoir should be considered. Thank you for your attention.
Thank you for the presentation. One first question. Everything is clear? No questions? Yes, please.
My question, and what temperature do you use and why?
We use a temperature 85 degrees Celsius because the area of interest of this rock is the heterogeneous rock of West Siberia. It's the average temperature of West Siberia fields.
Is it good result in the sphere, in the field?
This system, yes, they can make oil production higher, and oil production index can be higher 2 or 5%. Yes, it's good. But if we have layers with higher percent of place and carbonate, the results will be not so good, and we should consider that.
Good. More questions? No questions. We have for a review from the supervisor of the project, senior lecturer Потешкина. This review is positive. Thank you. And we go to the last application for bachelor degree. Уколов Илья, his work development and research of sedimentary and forming gels during multi-stage hydraulic fracture. This work was on the supervision made by supervision Professor Mazada. Please, forward.
Hello colleagues, my name is Уколов Илья, group XT1504. My Bachelor of Science research is development and research of sedimentary and gel forming diverter during multi-stage hydraulic fracture. Aren't you tired? Outside? Are you? I'll try to be as short as my associate. So, introducing the plan of my report, first of all, a short absurd of technologies of multi-stage fracture. Next, techniques of temporary isolation fractures is the most important step in this process. Then, we'll discuss chemical diverters for temporary isolation fractures, and the final part would be object of study, methods of experiments, results that we gained, and a short conclusion. A short observe of technology of multifrac. Multifrac is a process of injection of special liquid under high pressure that can make high conductive fractures to get regular production of hydrocarbons. It's a great multi-stage fracture is a great opportunity to extract hard to recover resources. So most of hard to recover resources extracted by multi-stage fracture. We use propant is a special material which will pump and maintain permeability of the rock and maintain to be open this fracture. So short actual information. Multifrac share is 11% for 2017, and the share grows to 41% by 2013. RPA agency data forecast. So overall number of stages also increasing from 2017 by 2013, as you see. Let's talk about reflector technologies. Reflector is the process of making a new one fractures, and it can provide open an old one fractures. So these two main technologies using frag ports and coil tubing, but they have their disadvantages, such as blind fracture. There are no possibilities to predict the new exact place of fracture, higher design costs, and some technical difficulties to set a cracker. Let's talk about temporary fracture isolation techniques. There are two main techniques, mechanical and chemical. Mechanical one represented by separation of frag ports by ball coupling, the first picture, and chemical is making special formation of deflecting screens by chemical diverter, which makes a special plug on the fracture port. So there are many technologies, but I've chosen the main two by Weatherford is T-block sure, represented by particles and granules, which are mixed and added to fraction fluid. Small particles fill highly permeable channels, and granules action in bottom hole area. The second one is a technique of Schlumberger, conventional reservoir fracture and diversion, represented by special substances, which are special fibers, multimodal particles, inertial additives. Our object of study is according mix containing aluminum polyoxychloride and carbamide. So once material dissolves, some reaction occurs. These are reactions. First reaction of conversion aluminum polyoxychloride, gelling reaction. Second reaction is hydrolysis of carbamide, and the last, third and fourth reaction is dissociation. Also, we can add some modifiers such as sodium acetate, urotropine, ammonium chloride, and xanthan to make variable time of gelling and and make rheological properties, different rheological properties by adding xanthan. These are methods of experiments that we have used. First experiment is temperature stability. To conduct thermostability experiment, Sedan's classifier must be used. So assessment has covered visually, and the optional consistency highlighted in green color, such as static gel, highly evolved static gel, and etc. The optional composition of our diverter showed by diagram and contains carbamide, polyoxychloride of aluminum, sodium acetate, urotropine, xanthan, and ammonium chloride. Also, filtration experiments have been conducted and used filter press fan, and degradation experiments have been carried out by adding acid solutions. The first experiment was temperature stability. There are three main temperatures: 60 degrees, 40 degrees, and 25 degrees. Such temperature was chosen since after the multi-stage fracturing process, the temperature decreasing in a well. So these are three main temperatures. And the time was chosen also since pumping from a surface our diverter to the exact place that we try to make a special screen. So it's 180 minutes. A green color suggests us static gel, so initial solution converted into a non-work static gel during the time. And also the water dosage was variable. Filtration through a high permeable propane pack illustrated the process in a well and in the lower oil field, where multi-stage fracturing being performed. So this model is a high permeable propane pack with permeability about 200 terci, and the experiment occurs a special diverter above propane pack. So at first we fill the bomb with 100 grams of propane 2040. Next, adding 300 milliliters of our solution. Then keep composition under pressure. Initial pressure is 1.4 MPa, and temperature is 70 degrees during 80 minutes. When valve has opened, the filtration began. The higher pressure we have applied, the more filtrate we have received, as you see in the table. Maximal pressure was 700 MPa. After that, there was a small leakage of air, and the diverter are able to make strong screen and hold up 700 PSA, which is 4.8 MPa. The last experiment was degradation by acid solution. First of all, we obtained a strong diverter called 8. Then we added some acid solution, as you see. Then mixing and get a soluble system. And it converted from insoluble system into soluble. Yeah, it's a easiest way to eject our diverter from cracked ports. So that's the experiment. And some conclusions. The optional recipe has been selected of our composition. Our chemical composition can be used at pressure up to 4.8 MPa and able to keep a strong screen. And degradation of diverter have been studied. So, thank you for your attention. If you have any question, please ask. I've got to answer your questions.
Thank you, Ilya. Please, questions. You mentioned about the orthopene and xanthan.
Yeah.
Yes. It seems to me it's pretty expressive things. Do they use it anyway?
Yes, we can use since the overage summary mass per percent is not so high as, for example,
Concentration is very small.
What?
You
Since-
take it in very small concentration. I mean,
Yeah,
what
since,
percent?
yes, as you can see
Mhm.
on the diagram, xanthan is about half a percent
Mhm.
in our composition.
Mhm.
So our diverter used in bottom hole, since the summary mass is not so high, it's not so expensive.
Mhm. So you use it
This
then, yes?
Yes,
Both,
of course.
and
Orachopin
and
xanthan also
Mhm.
have been used.
in very small concentration.
Yes,
Half a
just
percent.
to regulate some properties.
More questions, please? No questions. So, I should announce the review of supervisor, Professor Margadova. And this review is completely positive. So, let's see. Thank you.
Thank you for your attention. Thank you for listening.
You're very well. Так, so that we ask our students to leave us for a couple of minutes. Is that okay? Так, баллы уже готовы, да? Теперь мы должны решить, какие работы куда рекомендовать. По публикованию, к использованию методических материалов для использования в промышленности.
Ну, сначала вот какие фундаментальные работы? Кто это? Кто как будет, кто
Гидрирование точно.
это? Фамилию подскажете?
Так, гидрирование. They announce mark. Excellent, good, satisfactory. No? Good. I'll try. It's a great honor and great pleasure for me to announce the application results. Jabar gets 95 points and excellent mark. Tайлембаева gets 92 points, excellent mark. Гличева 97 points, excellent mark. Вагапова Юлия 98 points, excellent mark. Найманов Руслан 82 points, good mark. Макарова Арина 95 points, excellent mark. Никитина Ирина 96 points, excellent mark. And Polov Ilya 95 points, excellent mark. All masters recommended for post-degree education, and all bachelors are recommended to master degree application. Please accept my congratulations and wishes all the best in your life and bright achievements. Thank you for your presentation today. That's it.
Thank you.
Можно перейти на русский? Можно вас сфотографировать? Я думала, ты сейчас скажешь. Ну, я просто предложила как
Я вот сюда. Я сюда.
Спасибо.